Mars, the red planet. For centuries, it has captured our imagination. Its rusty hue, visible even to the naked eye, hints at a world of mystery and wonder. We've sent robotic explorers, rovers that traverse its dusty plains, and orbiters that map its every detail. But the dream remains, to send humans to Mars, to walk on its surface, to explore its canyons and volcanoes, and to search for signs of past or even present life. This ambition, however, is not easily achieved. Going to Mars presents immense challenges, pushing the very limits of our technology and our understanding of human resilience. The journey is long, the environment harsh, and the risks substantial. Yet, the allure of Mars is undeniable. It represents the next giant leap for humanity, a chance to expand our horizons and unravel the secrets of another world. The first hurdle to overcome is distance. Mars is, on average, 140 million miles away from Earth. That's a long way. To put it in perspective, this distance is equivalent to traveling around the Earth over 5,000 times. To put it in perspective, if we could drive to Mars at highway speeds, it would take about 228 years. Imagine driving non-stop, day and night for generations. It's a journey that would span multiple human lifetimes. Of course, spacecraft travel much faster than cars, but even so, the journey to Mars takes many months. Current spacecraft technology allows us to travel at speeds unimaginable in everyday life. Yet the vastness of space makes even these speeds seem slow. Current estimates suggest a one-way trip would last around 7 to 9 months, depending on the positions of Earth and Mars in their orbits. This duration is influenced by the elliptical orbits of both planets, which means the distance between them is constantly changing. This vast distance poses several challenges. The sheer length of the journey means that astronauts will be isolated from Earth for extended periods, facing both physical and psychological challenges. First, we need to develop spacecraft capable of safely transporting humans for such extended periods, providing them with life support, protection from radiation, and adequate supplies. The spacecraft must be a self-sustaining environment, capable of recycling air, water, and food. Second, communication with Earth becomes increasingly delayed as the spacecraft travels farther away. At its closest, Mars is about 35 million miles from Earth, resulting in a communication delay of several minutes each way. This delay makes real-time communication impossible, requiring astronauts to be more self-sufficient and able to handle emergencies on their own. They must be trained to operate independently, making critical decisions without immediate support from mission control. This autonomy is crucial for the success of long-duration space missions. Additionally, the psychological impact of such a long journey cannot be underestimated. Astronauts will need to cope with isolation, confinement, and the stress of being far from home. Comprehensive training and support systems will be essential to maintain their mental health and well-being throughout the mission. Despite these challenges, the journey to Mars represents one of humanity's greatest adventures. It is a testament to our ingenuity, resilience, and desire to explore the unknown. The great divide between Earth and Mars is not just a physical distance, but a symbol of the challenges we must overcome to reach new frontiers. Confined within a spacecraft for months, astronauts will face numerous physical and psychological challenges. The lack of gravity can lead to muscle and bone loss, as well as cardiovascular problems. Isolation and confinement can also take a toll on mental health, potentially leading to anxiety, depression, and interpersonal conflicts among crew members. Addressing these human factors is crucial for mission success. To mitigate these risks, mission planners are developing countermeasures such as exercise regimes, artificial gravity environments, and psychological support systems. Selecting the right crew, individuals with the right mix of skills, resilience, and compatibility, is also paramount. The journey to Mars is as much a test of human endurance as it is of technological prowess. We need to ensure our astronauts arrive healthy, both physically and mentally, ready to face the challenges that await them on the red planet. Section 4. Cosmic Speed Bumps. The journey to Mars is fraught with hazards. It's not just the vast distance that poses a challenge, but the myriad of dangers that lurk in the void of space. One of the most significant threats is space radiation. This invisible menace comes from various sources, including the sun and distant stars, and can be incredibly harmful to both equipment and human health. Unlike Earth, Mars has a very thin atmosphere and lacks a global magnetic field, leaving its surface exposed to harmful cosmic rays and solar flares. Earth's magnetic field acts as a protective shield, deflecting much of this radiation, but Mars offers no such protection. Prolonged exposure to this radiation can damage DNA, increasing the risk of cancer and other health problems. The effects of radiation are cumulative, meaning the longer astronauts are exposed, the greater the risk. Astronauts on a Mars mission would receive a significant dose of radiation, far higher than what they would experience on the International Space Station. The ISS is still within Earth's protective magnetic field, but a journey to Mars would venture far beyond this safety net. Protecting astronauts from this invisible threat is a major challenge. Engineers are constantly working on developing better shielding materials and methods to safeguard the crew. Spacecraft shielding, while effective to some extent, adds weight and complexity to the mission. Every additional layer of protection means more weight, which in turn requires more fuel and resources. Other solutions being explored include radiation-hardened habitats on Mars and medications that can help repair DNA damage. Scientists are also investigating the potential of using Martian soil and rock to build protective structures. Minimizing the time spent in space by developing faster propulsion systems could also reduce radiation exposure. The less time astronauts spend traveling through space, the lower their cumulative radiation dose. However, such technologies are still in their early stages of development. While promising, they require significant advancements and testing before they can be reliably used for manned missions to Mars. The journey to Mars is a monumental task, filled with numerous obstacles. But with continued research and innovation, humanity is steadily moving closer to making this dream a reality. The challenges are immense, but so are the rewards of exploring and potentially colonizing another planet. As we push the boundaries of space exploration, overcoming these cosmic speed bumps will be crucial. The future of space travel depends on our ability to protect and sustain human life in the harshest environments imaginable. Section 5. A harsh and alien world. Upon arriving at Mars, astronauts will face an environment far different from Earth's. The red planet presents a myriad of challenges that are both fascinating and daunting. The landscape is rugged and barren, with vast stretches of rocky terrain, hills, and craters that tell the story of a planet shaped by ancient volcanic activity and meteor impacts. The Martian atmosphere is thin, composed mainly of carbon dioxide, and the air pressure is extremely low. This thin atmosphere means that there is very little protection from the sun's harmful radiation, making the surface of Mars a harsh place for humans. The sky often appears hazy due to the fine dust particles suspended in the air, giving the planet its characteristic reddish hue. Temperatures on Mars are also extreme, ranging from a frigid -200 degrees Fahrenheit, -129 degrees Celsius, at the poles. These polar regions are covered in layers of ice, both water ice and dry ice, which is frozen carbon dioxide. The cold is relentless, and any exposed human skin would freeze almost instantly. To a balmy 70 degrees Fahrenheit, 21 degrees Celsius, at the equator during summer. However, these warmer temperatures are fleeting and only occur during the Martian summer. Even at the equator, temperatures can plummet dramatically at night, making it a place of stark contrasts. Dust storms, some of which can engulf the entire planet, are also a regular occurrence. These storms can last for weeks or even months, reducing visibility to almost zero and covering solar panels with a thick layer of dust, which can be a significant challenge for energy generation. These conditions make it impossible for humans to survive on Mars without specialized suits and habitats. The pressurized suits protect astronauts from the thin atmosphere and extreme temperatures, while the habitats provide a controlled environment where they can live and work safely. Astronauts will need to live and work in pressurized environments, venturing out only in their protective gear. These habitats will need to be robust and capable of withstanding the harsh Martian conditions, including the intense radiation and the abrasive dust that can infiltrate equipment and living spaces. Finding or creating resources on Mars, such as water ice, will be crucial for survival. Water is not only essential for drinking but also for growing food and producing oxygen. Extracting water from the ice deposits on Mars will be a key task for astronauts, and building materials will be essential for long-term missions. Utilizing the resources available on Mars, such as the regolith or Martian soil, to create building materials can help in constructing habitats and other necessary structures. This in-situ resource utilization can reduce the amount of material that needs to be transported from Earth, making missions more sustainable. By harnessing the resources available on Mars, we can create a more self-sufficient presence on the Red Planet, paving the way for future exploration and possibly even colonization. Section 6. Building for the Red Planet. Landing on Mars and living on its surface require technological feats beyond anything we've achieved before. We need to develop spacecraft capable of entering the thin Martian atmosphere and landing safely on its surface. Once there, astronauts will need habitats that provide them with a safe and comfortable living environment. These habitats must be pressurized, shielded from radiation, and able to withstand the harsh Martian conditions. Power generation is another crucial aspect. Solar panels, while effective during the day, need to be supplemented by other power sources such as nuclear fission reactors to provide continuous energy, especially during the Martian night. Developing these technologies is a complex and costly endeavor, requiring significant investments in research, development, and testing. But the rewards, pushing the boundaries of human ingenuity and paving the way for a future on Mars, are immeasurable.